Hi dear students, welcome back to computer science class. In our previous session we have seen data structure and stack in detail. Data structure means it's a logical way of representing data in computer memory. Then we have different data structures available in Python. Stack, queue, list, all are some of the data structures, and we are discussing stack, and we have seen what a stack is. And before that, data structure means it's a way of storing, retrieving and organizing data in a meaningful way, so it gives optimal performance, right? It works efficiently, and we are implementing it through data structure called list or data type called list. And we know the specialty of list, specialties of list. List is a heterogeneous data type, means we can store different type of data elements in a list, as well as it is dynamic in the sense we can increase as well as decrease the size of a list. It is not static, size is not fixed. Okay, then we have gone through different applications or different operations of stack, like creating a stack, inserting data element into a stack, then checking for empty stack, deleting from a stack, and of course displaying or traversing a stack. We know what a stack is. Stack is a linear data structure or is a sequential data structure in which insertion deletion through one end. There will be two ends, one end is closed, other end is open, and we perform insertion deletion, the main two operations through that end, and that end is called top of the stack. That opened end is called top of the stack, and it performs or it operates as LIFO, last in first out. Last inputted item can be taken out first because we have only one opening. And today we have the implementation session. We have seen different operations like push and pop and delete, all that. Then we have two examples today, two implementations. Okay, so straight to the topic. First one, implementation of list as stack. We know we are implementing stack as a list. What list is like a pen, and stack and queue are like what, drawing and writing, right? Stack and queue are just concepts, and list is the way we implement, where we create our concept, right? Yes. So implementation of list as a stack. Here in this program we implement push, pop and display, main three operations. Okay, yeah. And in between we are checking for empty stack as well. At the time of deletion we have to check it, otherwise we'll be going we'll be proceeding without having any logic sense, right? Okay, so we can start the program. S equal to square brackets, we know what it is. We have two ways to create a stack. One is using a list, using the list function, and as well as S equal to what, square brackets. Okay, we know it is an empty stack. It is an empty stack or it is an empty list. Actually it is a list, we are making it as a stack just by the operations. Okay, yes. Then S equal to here S is our stack, is an empty stack. Then C equal to Y, C is a variable storing Y. Then Y, we are starting a loop while C equal to Y. Initially the condition should be true, because otherwise we cannot enter into the loop, we cannot proceed further, right? So C equal to Y, we can get into the loop at first. Yes. Then print, we have three print options. Okay, we have three options. One is push, second is pop, and the third one is display. We are performing these three main operations in addition to checking for empty queue, empty stack. Okay, yeah. So after that we are initializing choice. Why choice? Because we have three options. Okay, we have to set the choice. Yeah, it's up to the user, right? Yes. So choice equal to int of input of enter your number. You know what int of input is? Int is a function, input is also a function. Okay, yeah, it converts what, the character to integer type, because here it receives 1 2 3. Okay, yeah, you can see 1 2 3. Yeah, so it should be typecasted to integer type. The input text string must be typecasted to integer type. Okay, so choice is an integer variable. Then if choice equal to 1, suppose we inputting, the user is inputting what value of choice is 1. We know it's for performing push operation, so we'll have statements to perform push operation here in if part. You can see A equal to input of any number, that's the number we are going to input. Okay, so input of enter any number, we inputting a number that will be stored in A. Then S dot append A, you know what append is? We are performing push operation, we are performing adding element to a stack or inserting element to a stack with the help of a function, list function append. Appending means adding at the end of. Okay, yes. So S dot append A. Suppose we inputting the value 5. Okay, first time we inputting 5. Yeah, 5 will be placed onto the stack. Here is our stack. We can have diagrammatic representation. Okay, 5 will be placed here. 0 1 2 3. Suppose we have 3 locations, okay. Yes, so this is our stack. So we have inputted what 5 first. Yes, then okay, if works, then finally it moves to what, c equal to input of do you want to continue, do you want to continue. Yes, we suppose we initialize it c with the same y, okay. Y means here checks y, we can enter into the loop again for performing any operation out of these 3. Yeah, so suppose we inputting y for c, then it moves to what, while condition c equal to y, yes, okay, yes. Then again we are selecting what, okay, we can leave that push for the time being, okay. Then we can move to what, elif choice equal to 2. Suppose the choice we inputting is the value of choice is 2. What happens? We know it's for pop operation, okay. We have a function pop, and here you can see if s equal to empty square brackets, what it means, it's empty, right, empty list or empty stack. If s equal to, that means we cannot perform pop operation. If there is nothing in the stack, we cannot delete any item. Simple logic, okay. Yeah, if there is no element in the stack, we cannot perform pop operation, that's it. Else means there is element, okay, or there are elements. Yeah, print deleted element is s dot pop. We know we perform pop operation using the function pop, right? Yeah, so s dot pop meaning the topmost element, the element which is what added at last will be deleted. Yes, then we, okay, if the choice is not 1 or 2, it moves to 3. Elif choice equal to 3, we know 3 is for displaying, okay. Yes, L equal to len of s, L equal to len of s. Suppose we with the value of c s what, c is y, and here choice is 1 for 2-3 times, okay. Yes, we will suppose we can have values 5.5 x, okay. Yes, so our stack is in our stack we have 4 elements, 5, t, 5.5 and x, right, okay. Yes, so yes, you know how to print it, how we are going to print it out. That's what choice 3's working is. Yeah, so choice equal to elif choice equal to 3, what happens, L equal to len of s. Here what is the value of len? It is 4, right? Length of the list or the stack is 4. We have 4 elements, 1, 2, 3, 4. Yes. So for I in range L minus 1 comma minus 1 comma minus 1. What is that? You know, a range function, right? Start, stop and step. Here the value of start is L minus 1 and stop is minus 1 and step is minus 1. Both stop and step, the value is minus 1, right? Okay. Why we are starting with L minus 1? L minus 1 means last minus 1, right? Here L stores the length of. So here in effect what will be the value of L here? It will be the length of S is 4. 4 minus 1 is 3. So L stores 3. Then L minus 1. Yeah. Here the value of L is 4. 4 minus 1 3. That is 3 will be displayed first. 3 will be printed first. Okay. Yes. It prints from last to first. That's a logic, okay. Yes, so here what, x prints first, x will be printed first, then it what, step is minus 1, right? Minus 1 means L minus what, 2, right? Yes, minus 1 means it moves to 5.5, so 5.5 will be printed second, then again t will be printed third and 5 will be printed at last. Yes, that's order of printing or displaying. Yes, and what is minus 1? That's stop. That means it will be excluded, right? Yeah, we don't have any minus 1 value here. Even if it is there is minus 1, it will not be printed, okay. It's up to minus 1, okay, excluding. Yeah, so then okay, we are printing each time, okay, values x 5.5 t and 5. So this is the order of what, printing in the case of what traversal or displaying here in this example. In any example we print from last to first, right? Okay, then finally else print wrong input, c equal to input, okay. Yeah, else means suppose you are inputting some other value other than 1 2 3, what happens? It must show what, wrong input. Suppose you are inputting 5 for choice, what happens? It must not be executed, okay, because we have only 3 if elif structures. Yeah, then c equal to input of do you want to continue. Yes, so this is how this function works, and we have seen the working of push operation, right? Then now we can go for pop operation. Yeah, we have already completed push and display functions, right? Display, yeah, methods. Yes, Then we can go for choice 2. Okay, yeah, suppose we inputting what the value of choice is 2, then elif choice equal to 2. We know our stack is not empty, we have four elements in the stack, so it moves to else. Deleted element is s dot pop. What happens? This will be deleted, right? The topmost element will be deleted because top points to this element. Okay, it follows LIFO, last in first out structure. Then just after deleting the topmost element, top points to 5.5. Okay, then again suppose the value of choice is 2, what happens? It will delete 5.5. Okay, then next t, then 5. Okay, that's the order. Yeah. So this is how we can implement list as stack or stack as a list. Okay, yeah, stack is only a concept. We implement it through list. We have created a stack first, then c equal to y. Okay, we have three options: push, pop, and display. Then input initializing choice, and if choice is 1, we are performing push operation. If choice is 2, we are checking for empty stack. If the stack is empty, we cannot perform pop operation, right? Yeah. Otherwise, using s.pop function, we can remove it out, pop it out. Yeah. Then choice equal to 3. It's for displaying, traversing. First we are finding the length. Then we are starting with l-1, ending with -1, and stepping with -1. Right? We are printing each time. Then we know the specialty is we print from last to first. Okay? Yes. So else what happens? It's a wrong input rather than 1, 2, 3. Yeah. Then do you want to continue? You can perform any number of input or output. Okay, whatever it is. Yeah. So this is our first implementation, and we can go for the second implementation. Here is our second example. It's for displaying unique vowels present in a given word. We are counting the number of unique vowels, not repeating one. Unique vowels present in the given word. We are initializing the word. We can go to the program. Initially we are setting vowels. Vowels equal to A, E, I, O, U. We are initializing vowels because we have to specify which are the vowels, right? Yes. So initially we are setting vowels A, E, I, O, U as vowels. After that we are initializing word. Word equal to input of enter the word to search for vowels. We are searching for unique vowels, right? Yeah. Here is a sample word, hello Python, and we are counting the number of unique vowels present in hello Python. That's a sample string, sample word. Then we are initializing an empty stack because we are storing unique vowels in that stack, right? That's the use of creating a stack. Then into the loop, for letter in word. For letter in word, we are searching for what? Word. Okay, we are in word. Hello Python. That's our word. Letter in word. If letter in vowels. If letter in vowels. If letter in word means it goes from HELLOPYTHON one by one. We know that. Okay. So initially it's with H, right? Yeah. If letter in vowels. H is not in vowels. Can you see H now? Yes. Then if letter is in vowels, it into the loop. Otherwise, it moves to for letter in what word again, right? Yeah. So E letter, the value of letter is E, and if letter in vowels, E is here in vowels. So what will be stored in the stack? S. There in S, there will be E, right? E will be stored onto the stack. You can see if letter not in stack. No, E is not in stack. Letter in vowels. E is in vowels. If letter not in stack, E is not stored in stack. Then why it's letter not in stack? Because it won't give or store repeated vowels, right? Vowel will be unique, will be stored only once. Yeah. Then letter not in stack, E is not in stack. Stack dot append letter. So E will be stored in the stack. E will be stored in the stack. Then yeah, it moves to letter. The value of letter will be L. If letter in vowels now, then again to the second L, not in vowels, not in okay, yeah, not in vowels. Then O, yes, for letter in vowels, yes, O is here in vowels. If letter not in stack, no, it's not in stack. We have only E in the stack, right? Yeah. Then stack dot append what? Letter, okay? That means O. Okay, yeah, all be there in the stack. Then what? P. The value of letter is P. Then letter not in vowels, no. Then Y, no. T, no. H, no. O, yeah. When the value of letter is O, what happens? If letter in vowels, yes, O is here in vowels. Then if letter not in stack, it's not true because letter is in stack. O is already stored in the stack. So it will not be what? It will not append. Okay? Yes. The condition becomes false. because if letter in stack, that's a condition, because it's already there, so the condition becomes false. It will not append, it will not push or again onto the stack. Okay, it will not push or it will not add or. We have two O's. First we have stored this A O, then when we reach there in the second O, it will not be pushed onto the stack. Yes. Okay, then finally N, no. Okay, then break out of the loop and print stack. Stack will be printed. Okay, yeah. Then print the number of vowels present in word is 2. Yes, we have only 2, right? We have only 2 what vowels present in the stack. So here is our second example. You just go through some more examples. Okay, first you go and get a thorough knowledge, okay, or skill on these two problems. Okay, after that you can create or you can go for some more problems. Okay, push, pop, and display, plus some other generalized problems. Okay, as we are. So this is all about the implementation of stack. Okay, we have gone through what a stack is, operations on stack, and finally implementation of stack. So this is all about stack, and our next concept is queue. Queue is also something like somewhat a structure like stack, but stack is having only one opening, the other is having 2 openings. Okay, that's a difference. It's like a real queue. You know the working of real queue. There will be one and then means 2 ends. Okay, yeah. So that's what and in queue also we are following the same kind of pattern. First we'll define what queue is and operations, push and pop, then ends. Okay, front and rear, all those. After that we'll move on to the operations, finally implementation, okay, and application. Yes, so this is all about the stack implementations, and now we're going to look at the applications of stack. Okay, the applications of stack in computer science. After that we can move on to what queue, the concept of queue and its implementation. Okay, and here is our final topic in stack, applications of stack. We have gone through all the theory as well as implementation of stack. Now we are looking at the applications of stack, computer based application, computer related applications. Okay, we have already seen some of the applications. Yeah, reversing a word or a line, then using compilers, using backtracking is a kind of recursion. Yes, then undo mechanism in text editors. We can look at reversing a word or line. How it reverses a word, you know, stack performs operates like LIFO, last in first out, right? Last inputted item can be taken out first. So it processes in reverse order. It can be used for reversing a string or reversing a line or reversing a word, because you know how the things are popped out and how the things are pushed onto the stack. Yes, it's in reverse order. How we are pushing, and pop is performed just in the reverse order of push, right? Yes, so it can be used in reversing a string. Then using compilers in the sense, at the time of calling a function. Yesterday in our previous class I've told you about main calls A calls B, then which one will be executed first? B, right? Then it moves to A, finally to main. We have placed main first, then A, then B. So B will be executed first, popped out first, then it moves to A, then finally to main. Means main executed only at last. That is the one inserted or pushed to the stack first. Okay, so it can be using compilers in programming. Yeah. Then backtracking, it's a kind of recursion. Okay, so in backtracking also we use stack. Yes. Then optimization algorithms like knapsack, we use this stack for its performance. Okay, its operations. Yeah. Then undo mechanism in text editors, as I've told you in our previous class, it can be used for undo mechanism, right? Undo back. Yes. So undo mechanism in text editors. There also we are using the application of stack, and we have seen another application like browse the internet. You know how it moves from one to another, then at the time of back, pressing back, which moves to previous is, that's the order of execution. Okay, so this is all about stack theory, stack implementation, and stack applications. Okay, so now we can move on to our next topic, and it will be discussed in the next class. Okay, so this is all for the time being. Thank you for watching. Just go through all these topics and have enough practicals. Okay, yeah, make sure that you are doing enough practicals and more by yourself. Okay, just find out some more problems and do it yourself. Yes, you can, so many problems are available. Okay, you can refer to a text, or you can go on internet. Okay, whatever it is, you can take on any medium. Okay, whatever it is. Yeah. So make sure that you're skilled. Okay, you're getting skilled. Yeah. So this is all for the time being. Thank you for watching. Have a nice time.